In this video, we are going to look at science paper 1 for the year 2024 for internals, and our focus will be on section B. So we have question 1, figure B 1.1 is showing the time recorded on a stopwatch for 40 complete oscillations by Elena during an experiment on a simple pendulum. So the first question is, state the time taken in seconds for 40 oscillations. So on our stopwatch here, we have 01, 40, 00. So the first two zeros represents what we call microseconds, and we don't have any microsecond. Here we have the seconds, so we have 40 seconds, then 1 minute. Now, since our question is in seconds, I'm going to change 1 minute into seconds. So remember, 1 minute is equal to 60 seconds plus this 40 seconds. So this adds up to 100 as our final answer. So we can now move on to question B. Calculate Roman number 1, period of the pendulum. So period is the time taken for one complete oscillation to be made. So it's denoted by capital letter T, then small letter t divided by small letter n. So small letter t is the time taken, 100, over small letter n is the number of oscillations, so we have 40 oscillations. So if you divide these two numbers, you get 2.5, then the units are seconds. So this simply means that after 2.5 seconds, one complete oscillation was made. We move on to question Roman number 2. We just need frequency of the pendulum. So frequency refers to the number of complete oscillations that are made in 1 second, like how many oscillations are made in 1 second. So to find frequency, you say frequency is equal to, and you use small letter f, 1 divided by period. So 1 over the period, we say is 2.5. So 1 divided by 2.5, you get 0.4 Hz. So this means that every 1 second, 0.4 Hz were made. Or if want, we can also find the same frequency, but we need to use the reciprocal of the formula for period. Instead of t over n, you say n divided by t. So n is 40, t is 100, you still get 0.4 Hz. We move on to question number B. So it's all about how much have you understood and what you can memorize from what it states. So B2, state Newton's second law of motion. So it states that the acceleration is directly proportional to the net force. And is inversely proportional to the mass being accelerated. So from this law, we can make some interpretation, and the first one is like the relationship between acceleration and net force. So we are told it's directly proportional, which simply means that if we increase the net force, the acceleration will also increase. So that is a direct proportion. Then for mass, we are told that the acceleration is inversely proportional to mass, which tells us that if the mass of an object is increased, then the acceleration will decrease. We move on to question B. A block of mass 500 grams is pulled from rest. So the word rest here simply means the initial velocity is 0 on a horizontal friction bench by horizontal force F and attains a velocity of 8 meters per second. So this was final velocity. Then we have T. Calculate Roman number 1, uniform acceleration of the block. So acceleration for this one we can say is equal to final velocity is given, remember, initial is given over time. Then acceleration is equal to final is 8 minus initial is 0 over 2. So 8 minus 0 is 8 over 2. Here we are going to have acceleration is equal to 2 into 8 is 4. The units are meters per second squared. So acceleration tells us how fast or slow the velocity is changing. Then for Roman number 2, we just need the value of F, which is net force. So force is equal to mass by the acceleration. So from the given information, the mass is given in grams, but according to physics, the mass should be in kilograms. So you need to use this conversion. So you need to say 1 kg is equal to 1000 grams. So the 500 grams, I'm going to put where grams is, then we put x, we cross multiply. 1000 grams multiplied by x is 1000 grams x. 500 grams times 1 kg is just 500 grams kg. So you divide by 1000 grams and also here by 1000 grams. So x is equal to 0.5 kilograms. Or to summarize our work, we are saying whenever you are changing from grams into kilograms, you just need to divide by 1000. So the simple way is 1 kg is equal to 1000 grams. So to change from kg into grams, multiply by 1000. Then from grams to kg, just divide by 1000. So we can say force is equal to, our mass is 0.5 times the acceleration is 4. So 0.5 times 4 will give us 2 newtons. Now we say the force is directly proportional to acceleration. So let's try to make some sense out of this. So let's say we are going to maintain mass at 0.5 kg. Now what happens if we change the value of acceleration? So the first value of acceleration is 4. Now let's double the acceleration. Let's say the acceleration is 8. So let's find our new value. So let's find our new value for force. So we can say force is equal to mass times the acceleration. Force is equal to, the mass is 0.5, the acceleration is 8. So force is equal to 0.5 times 80, just get 4 newtons. So as you can see, we doubled the acceleration from 4 to 8. Then our net force also was doubled from 2 to 4 newtons. So that is the relationship of direct. If one quantity increases, the other quantity will also increase. Then we move on to question number 3 from the topic of light. Figure B3.1 is showing a simple pendulum, not light, a pendulum, both of mass 200 grams swinging from position A to position A. So we have the level ground. So this is our height. Then we have the rest position. So rest position here. So we can now move on to question number A. So at position B, the pendulum bob is 120 millimeters away from the ground and has a speed of 0.90 meters per second. Calculate the kinetic energy of the bob. So Ke is equal to half times mass times v squared. So we have half times what is the mass? So the mass is 200 grams. So you need to change, and we said to change from grams into kg, just divide by 1000. So this will give us a 0.2. So we have 0.2 times 0.90 squared. So here we just have to do some calculations. So 0.90 squared will give us 0.81 times 0.2, then divided by 2. So according to my calculations, I'm getting 0.081. The units are joules. That's our final answer. Then for question B, we just need gravitational potential energy of the bob. So potential energy is equal to mass multiplied by g times height. So the mass is still the same, is 0.2. Gravity is 10. What of the height? So the height is 120 millimeters. So we need to change into meters. So we know that 1 meter is equal to 1000 millimeters. So I'm going to put my 120 millimeters here. X we cross multiply. So 1000 millimeters X is equal to 120 millimeters times meters. So you divide by 1000 millimeters, also here by 1000 millimeters. So to summarize our work, you just need to divide by 1000 when changing from millimeters into meters. So we have 0.12. So we'll say 0.2 times 10 times 0.12. So I'm getting 0.24 joules. Then internal energy of the bob. So internal simply means the sum of the kinetic and potential. So you say internal energy is equal to PE plus KE. So you need to add the two numbers. So PE is 0.24 plus 0.081. 0.24 plus 0.081. I'm getting 0.321 joules. Let's go to question B4. explain what happens to the particles in solid when the temperature rises. So if you were to maybe come up with a simple illustration, in a solid we say the particles are closely packed. And the reason why they are closely packed is because the intermolecular forces of attraction here is strong in such a way that it manages to bring the particles closer to each other. So in a solid, there are no spaces. So now the question is, if we are to increase the temperature of a solid structure, what are we doing? So what we are doing is we are adding the kinetic energy to these particles. So after a certain period of time, the particles becomes energetic, and because they become energetic, they'll start moving, but vibrating. So we'll say the particles will become energetic and starts to vibrate at a fixed position. So because if let's say this is a particle and this is a particle, so this will start to vibrate and this one will also start to vibrate. Now since there are no spaces, the vibration occurs in a fixed position. So let's have question B1. Which of the three states of matter generally expands the most when heated at the same temperature? So we are going to have gases, because in a gas we know that the particles are spacely packed. So when they become energetic, they will start to move at a faster speed due to the spaces between the particles. So we can say because there are spaces between the particles. Then we have question C under the gas laws. A fixed mass of gas occupies a volume of 200 cubic centimeters at a temperature of 27 degrees Celsius and a pressure of 150 atm. If the temperature is kept constant, so this point is very important. You need to understand the factor which was kept constant, and the reason is that factor must not be part of your calculations, must not be in the formula. Find the volume when the pressure reduces to 100 atm. Maybe let's try to collect the data. So I'm going to start with volume 1. So the first volume before the reduction, volume 1 was 200 cubic centimeters. Then find a new volume. So we need volume 2. So the initial is 200, the final is not given. So let's move on to pressure 1. So pressure 1 is 150 atm. Then pressure 2 is 100. So if we are to look at this one, if you decrease the pressure from 150 to 100, will the volume increase or decrease? So you need also to look at the relationship between volume and pressure. when the temperature is kept what? Constant. So now, what I need for you guys to remember is, you need to remember this formula. So the formula is pressure 1 times volume 1 is equal to pressure 2 times volume 2 over pressure 1, over temperature 1 over temperature 2. So with this formula, you can make any of the formulas that you are given under the gas laws. You can make Charles' law, Boyle's law, Lussaki's law. So how do you make the formula that you want? You need to look at the fact that was constant. So the fact that was constant is temperature. So I'm going to say temperature is constant. So since temperature is constant, I need to get rid of T from this formula. So I can just cancel the T. When I cancel the T, I'm going to have P1 times V1, P2 times V2. So this is the formula that you are supposed to use. If volume was constant, you cancel V. What remains is what you're going to use. For example, if we say P1 V1 is equal to P2 V2 over T1 over T2. If volume is constant, you cancel V. Then the formula that you're supposed to use is P1 over T1, P2 over T2. So in a case where you forget the formula, this is what you're supposed to do. So pressure 1 is 150, volume 1 is 200, pressure 2 is 100, volume 2 is what we want. So 150 times 200 will give us 30,000. Then we have 100 V2. So over 100 over 100. So that's our V2. So our V2 is 300 cubic centimeters. Now let's look at let's analyze if this is making sense. So if you look at volume 1, so volume 1 is 200 cubic centimeters. That is our volume 1. Then volume 2, according to our calculations, we have 300 cubic centimeters. So volume 1 to volume 2. So volume increased. Now what of pressure? The pressure 1 is 150 atm. Then the pressure 2 is 100 atm. So what happened to pressure? The pressure decreased. So the relationship between the two quantities is that pressure is inversely proportional to volume. If you increase the pressure, the volume decreases. If you increase the volume, the pressure increases. And with this, you can state the law that you are given. In case they tell you, if you state Boyle's law, Charles' law, whatever law that you are given from the calculations, you should be able to state that. So I hope you've gotten something from this. We move on to question number 5. So question number 5. A person hears an explosion of fireworks from the neighbor's house. How far does the sound wave travel in air after 3 seconds? Take the speed of sound in air to be 340 meters per second. So formula, speed is equal to distance over t. So if we are to make d the subdue formula, we get d is equal to speed times t. What is our speed? So speed is 340 times time is 3. So we have 0. 3 times 4 is 12. We keep the 1. 3 times 3 is 9 plus 1, 10. So 1020 meters as our final answer. State one factor which influence the quality of sound. So we have pitch, even amplitude. Even timber. We move on to question number 6. Figure B 6.1, drawn to scale, shows a ray of light PQ striking a mirror AB. The mirror AB and the mirror CD are at right angles to each other. QN is the normal to the mirror line AB. So right angle to each other means that here we have an angle of 90, so we have the value of 90 degrees. What is the value of the angle of incidence I of the ray PQ on the mirror AB? So we need to identify where the angle of incidence is. So it is between the incident ray. So this is our incident ray. Then we have the normal ray. So the angle formed between these two lines is what we are looking for. Now remember that the normal ray is perpendicular to the reflecting surface, which simply means that here the angle adds up to 90. So if we have angle Y and angle X, so the sum of these two angles adds up to 90. So X plus Y is equal to 90. Excuse me. So what's our Y? We have a 50 is equal to 90. So if we shift to this side, you get 90 minus 50, giving us a 40. So the value here is 40 degrees. Or the simplest way is to find the angle at this point. Just subtract the given number from 90. So here we have 40. Now for question B on figure B 6.1, continue the ray PQ to show the path it takes after reflection at both mirrors. Draw to scale. So whenever you're told to draw to scale, you need to make sure that your drawings are perfect. You need to make the measurements accurate, use the instruments. But I'm going to use my free hands. So the first reflection will occur at this point. So this is the reflected ray. This is the reflected. So the reflected ray becomes the incident ray on the second reflection. Then we have our new normal ray like this. Then also what you need to know is the angle of incidence I is equal to the angle of refraction according to the laws of reflection. So what else? We've done this question. See, what is the value of the angle of refraction at CD? At CD. So the angle of refraction at CD is this angle here, because the line CD is this one. So what is this angle? So let's do some math. We know that a straight line adds up to 180. So we have 50 plus 40 plus 40 plus this angle must add up to 180. So 40 plus 40 is 80. 80 plus 50 will give us 130. So here we are going to have a 50 degrees. Now since this is a 90, so we are getting a triangle. So to find this angle here, we can just add these two angles. 90 plus 50 will give us 140. Then if we subtract, if we do this, 180 minus 140 will give us a 40, which simply means that there is a 40 here. If there is a 40 here, there is a 50 here, there is a 50 here, there is a 40 here. So the angle of reflection at CD is 50 degrees. Question D. What do you notice about the path of the ray PQ and the final reflected ray? So the ray PQ is this ray here, and the final is this one. So if you look at these two lines, they are parallel to each other, but in the opposite direction. So PQ, so the two lines are parallel. Excuse me. The two lines are parallel to each other. But opposite in direction. Let's go to question number 7. Figure B 7.1 shows a circuit with two resistors in parallel connected to a 10 volts battery. So resistor 1, resistor 2. What is the effective resistance offered in the circuit? So effective resistance simply means total resistance. So if you have two resistance, you can just go direct. RT is equal to resistor 1 times resistor 2 over the sum resistor 1 plus resistor 2. So total resistance is equal to resistor 1 is 3 times 6 over 3 plus 6. So 3 times 6 is 18. 3 plus 6 is 9. Then we have 2 ohms. Now if we are to redraw, we can come up with something like this. So we've combined the two resistances to make one. So I have 10 volts, then we have 2 ohms. So this is what it simply means. So you have combined the two to make one resistor. What of question B? Calculate the current flowing from the battery. So current is equal to voltage divided by total resistance, since we are interested in the battery. So as our voltage is 10 over total resistance is 2, giving us 5 amps. Determine the charge flowing through the battery in 1 minute. So charge denoted by capital letter Q is equal to current times T. Now, since we are given in minute, change into seconds. Remember, I said 1 minute is equal to 60 seconds. So say charge is equal to current is 5, time is 60. This will give us 300 coulombs. That's our charge. Then we have question 8. Figure B 8.1 shows a part of an electric device. Identify the electric device whose part is shown. So cathode ray oscilloscope. Name the part labeled Q. So what is our Q? Q is cathode. So when cathode is heated, it grows red and starts to emit electrons by the process known as thermionic emission. Now state one function of the part anode. So anode, we can say to accelerate the speed of electrons. Then part labeled Q, to produce the beam of electrons. When heated through the process known as thermionic emission. We move on to the last, the last question for question 8. Why is the space between part Q and the anode a vacuum? So we can say to prevent the electrons, the beam of electrons, from colliding with particles. So we need to make sure that the space is evacuated. Then we have question number last. A radioactive isotope X has a half-life of 6,000 years. Define half-life, so the time taken for the radioactive sample to decay by half. Then what fraction of the radioactive isotopes decays? So the key is here, decays after 2,000 years. So the half-life is 6,000. Then after 6,000, another 6,000. The second decay will give us 12,000. So here we only have 2 decay. So what do? You say 1 multiplied by the first half. So 1 times half is half. Then the second, the same half times another half. So here we are going to have 1 over 4. So 1 over 4, now we subtract from 1 to see what remained. So the lowest common denominator is 4. 1 into 4 is 4 times 1 is 4 minus 1, which is giving us a 3 over 4. If you want, you can also use this formula. N over N initial is equal to half times the number of half-lives, which is N. Now to find small letter n, you can say n is equal to time taken over half-life. So this should be small letter t. So the time taken is 12,000 over 6,000, giving us a 2. So if you were to use this formula, you can say n over NO is equal to half n is 2. So in n is 2 is 1 over 2 times 1 over 2, which is 1 over 4. As we can see, we are still getting the same final answer. Then you do the subtraction. The activity of the freshly prepared radioactive X is 4,000 counts per minute. How long will it take the activity of the sample to fall to? Excuse me. So let's do this visually. So we have 4,000. So let's do the first decay. Decay number 1 will remain with 2,000. Decay number 2 we have 1,000. Decay number 3 we have 500, because our key is here. So now the question is how long? How long? So from here to here we have 6,000. Then from here to here 6,000. From here to here 60,000. So if you are to add, you get 18,000. So here you get 18,000 as the time taken. If you want, you can use this formula. N is equal to T over half-life. N is the number of half-lives. So I have 1, 2, 3. T is what we are solving for, over 6,000. Over 1, we cross multiply. So T is equal to 18,000. Should be years. So years, that's our final answer. Then suggest one precaution that should be taken when handling radioisotope X in the laboratory. So these are just safety precautions, like wear badges or gloves, whatever thing that you can use to protect yourself from diseases like cancer. So as you can see, the paper was just okay. So that's it for this video. Thanks for watching.